Good.
Hello everybody, if you guys comment your names and we'll do a quick register. There it is. Right, so we've got Ed, there you are, we've got Harry, where's Harry, oh, another class, yeah, cool. Finn, yep, Jake, cool, Grace, yep, Melissa, yep, Molly, Emerald, Rob, and Dan. Cool, anyone, well, at least we've heard from anyone, is Ollie, Elizabeth, Jasmine, Jack, Poppy, Jolie, or Dom there? If you are, can you guys drop me an email to say that you're here? Alright, so for today we'd start looking at vectors. I'm just going to have a quick check and see where we got to last lecture, because I can't remember where we got to our integration, whether we left it on anything or not. Give me a sec while I check that. We've already... Oh, we didn't have Friday as methods, no.
Do a bit more integration next.
Where did we get to? It looks like we were doing... Oh, we're doing those horrible integrals, weren't we? Okay, what would you guys prefer to do today? We can either look at area integration, or we can... I'll pop it here as well. Either look at area integration, or we can look at vectors. What else did I have written down? We'll do proof at some point as well. And functions. I'm sure there's something else people wanted me to do. Vectors, yeah, we'll do vectors today then. That suits me. So, there it is, vectors, parametrics, and separating variables. Okay, with vectors, I feel like I started this lecture with another group yesterday. I did indeed. Cool. Right, vectors. So I think the two... Oh, Jasmine says, well, I'll just swipe you in. I think the two most important concepts in vectors is direction. Well, the most important is direction. And then after that, sketches. So sketches are really important. And whether lines are parallel. That also fits into direction, but I'll mention here as well. If you can understand and be able to use those three ideas, vectors should be a pretty easy topic. Because all we're ever doing is multiplying and adding stuff together. What makes it hard is understanding how to involve those three things. So we'll start with just talking about direction. So if I draw some axes, we can always imagine our vectors on a set of coordinate axes. We can never draw it wrong. As long as our arrows are the right way around, you can't draw vectors wrong. So if I had two vectors that have OA 1 minus 2 0 and OB 2 3 minus 9, those are in 3 dimension. I can't draw those. It would be impossible. So I'm going to draw those on a 2D sketch. I'm just going to put A here, put B here. So whenever I draw vectors, I just spread them out. I don't want them all cramped together. I just put 2 dots somewhere where there's a bit of space between them, and then we're done. That's it. So my vector OA is going to be the vector from the origin, which I'll label as well. O to A. And O to B is my other vector, O to B there. Alright, so we need to use the triangle law if we want to try and find AB. So AB, this vector here, A to B. To do that, we're going to go from A back to the origin, and then up to B. So we're going to go minus A plus B. That's where we get the equation AB is OB minus OA. So I can find AB. It will be 2, 3, minus 9, take away 1, minus 2, 0. So AB turns out to be 1, 5, minus 9. So that's how you can work out vector, and also how you can sketch it. Now we could make it harder. We could say, all right, there's another point involved. Let's put point C in this. So if I put C on this line, because C is on the line, A to C must be lambda A to B. They're parallel, okay? They're parallel because they're on the same line. So AC is part of AB. So those are what we get. We get parallel vectors. We could use that to find C or to find the origin to C. So if we wanted to do that, if we wanted to find OC given C splits AB in the ratio 2 to 1. We could use that to now try and find where C is. So I'm basically saying A to C is 2/3 of A to B. So I know what lambda is straight away. A to C is 2/3 A to B. So if I want to get from the origin, oops, let's keep that. If I wanted to get from the origin to C, I could go O to A to C. So I'm going to clear a bit of space down here because I don't need B anymore. So we can say OC is O to A plus A to C. We can explain that a bit further. Here OC is OA plus lambda AB, because AC is lambda AB. We know lambda is 2/3, so OC is OA plus 2/3 AB. And we could put all that together, so we could say AOC is OA, which was 1 minus 2, 0, plus 2/3 AB, which was 1, 5, minus 9. And we can work it up. So OC is 1 plus 2/3, so that's going to be 5/3, minus 2 plus 10/3, calculate the number. That's 4/3. And 0 plus 2/3 of minus 9, or 2/3 of minus 9 would be minus 6. So there's OC. So by doing a sketch, putting things on the sketch accurately, using lambda and mu for whenever there's parallel things, vectors shouldn't be a hard topic. So we're going to go over the geometrical stuff today. One thing we're not going to cover is finding a unit vector, so we'll do that now really quickly. So unit vector has magnitude of 1. So vector A was 5, 2, 7. Unit vector A, we put a little hat on it. I don't know what this is. Unit vector A over hat. The way we do it is we divide A by its own size. And that shrinks it. It's forced it to have a size of 1. So if I work out the size of A, that's going to be the square root of 5 squared plus 2 squared plus 7 squared. So that's going to be square root of 25 plus 4 plus 49, which is root 78. My unit vector A is going to be A divided by 1 over 78. So there we go, 1 over 78, 5, 2, 7. And that is a unit vector of size 1 in the direction A. Okay, so we're going to try a few of these. Starting with this one, which I think was in one of the mocks you guys did at some point, so we'll see if you can remember it. So I need to draw that sketch. Okay, I think I can handle that. So a triangle. A, O, B. All right, could you guys give this a go? I'll give you, how many marks is this? 6. I'm going to give you 8 minutes because I know these are quite hard at first. So 8 minutes. Comment if you need any help. Go Ollie, I'll take you off the register now. 8 minutes starting from now, guys. Cool. Yeah, Elizabeth, I was going to say yeah, but we may as well just go through it. You can check it then. Oh, you sent me anyway. Let's have a look. What's wrong with yours is your sketch. Your C is in the wrong place. And I'll show you why now. Otherwise, everything looks good. Your workings are correct, but C, you started off in the wrong place. So, OC is 2OA, so it's got to be in the same direction. O to C is OA, and then another OA. So I can imagine putting another OA on here, and that's where C is, up there. Okay, so A is A, B is B. We want to find C to... Okay, M is the midpoint of AB, so we'll put another point on here. M. We want to try and find C to M. So, we want to try and find this part here. How are we going to do that? Well, instead of going from C to M, we're going to go C to A to M. So we need to find CA. Well, if O to C is twice O to A to C is just going to be A. So C to A is going to be minus A. So let's write out the whole plan for this then. I'll just get a photo of some paper quickly. There we go. Cool. So, plan is C to M. C to M, we're going to go C to A plus A to M. A to M is half of A to B. So we can write this out again. CM is CA plus half AB. Now we know C to A is minus A. So CM is minus A plus half AB. AB is going to be B minus A. So plus half B minus A. Cool. We also need to simplify this. So we're going to get CM is minus A minus a half A is going to be minus 3 over 2A. And then plus half B. So that's what we get for C to M. Okay, I'm just going to move this up because we don't actually need that stuff anymore. Next, we want to try and find O to N. So I'm going to keep CM, I'll write it up the top here. I'll get rid of this so we've got a bit more room to deal with. What's N? Okay, N is where CM cuts OB. Okay, I left that bit out. So this blue line cuts B at point N. And we're trying to find O to N. All right. So we want to try and find this vector here now, O to N, which is going to be part of O to B. So we'll start by saying that, I think. ON equals half no. I'm doing part C there. We'll keep that for later, but we'll come back to that. So O to N is going to be if you like, we can go from O to C to N. No, O to... Yeah, O to C, and then part of C to N. Yeah, that's good. So that's the plan. O to N equals O to C plus lambda C M. Lambda's not going to be it'll still be a fraction. It's not going to be like it's not going to be part of Cm. It's going to be bigger than Cm, but it's still going to be, it'll be a top-heavy fraction is what I'm trying to say there. So O to C is 2a plus lambda, and Cn is what we found just now, minus 3 over 2a plus half b, which looks kind of close to what they've got. They've just taken all the a bits together and all the b bits together. So I'm going to expand the brackets and collect all my a terms. So On equals 2a minus 3 over 2 lambda a plus half lambda b. So it's looking close. All I need to do is factorize a outside of the first two terms there. So we get On equals 2 minus 3 over 2 lambda a plus half lambda b. And we're done. So that's part B. Part C is basically trying to find what lambda is. And lambda will come out as a fraction, which will let us find the ratio. So to do this kind of question, we always find two different routes to n. So one of my routes is go O to C to n, like we just did. The other routes can be go O to directly O to n. So On, as I said just now, is mu OB. We also know On is 2 minus 3 over 2 lambda. If I put OB in, OB is just B, so that's mu B. Because those lead us to the same place, I can set them equal to each other. So I'm going to say mu OB, sorry, what was it? Mu B equals 2 minus 3 over 2 lambda A plus half lambda B. Now, weirdly, one of our equations has no a's in it, which we kind of expect because O to n shouldn't have any upper bits in it. And then we got this one here. So we've got two choices to solve this. We could say mu equals half lambda. We can also say 2 minus 3 over 2 lambda equals 0 because there's no a's there. So we're going to set up two equations using the a bits and the b bits. So the a bits lead me to 0 equals 2 minus 3 over 2 lambda, and the b bits lead me to mu is half lambda. We're trying to find mu because we want to find the ratio it divides OB in. So we're trying to find mu. To do that then, I'm going to put, if mu is half lambda, I'm going to rearrange that to get lambda equals. So lambda is 2 mu. Put that into there. We get 0 equals 2, take away 3 mu. So mu is 2/3. So what we found is that n is 2/3 of the way. 2/3 of the way along OB, which we expected, and we've therefore proven that the ratio OB to NB is 2:1. Cool. So that's how you do that one. That's a pretty typical vectors question. So sketch, some lambdas, some mu's. Alright, I'll let you guys try this one next. Students always find this difficult. My best students struggle with this one. So have a think about how you can do this. 5 marks. I will give you 7 minutes because it does take a bit of pondering. So 7 minutes starting from Right, how do we get on, guys? Because as I said, these are often. This one was quite hard. Okay, I'm gonna give you a sketch. No one's answered it yet, so not gonna tell you this one until you figured it out. Part B is not too bad. Part A though, a bit difficult. Only 1 mark though. So two non-zero vectors. A plus B equals A. Mod of A plus B equals mod A plus mod B. Explain the significance. I'm gonna sketch it. I'm going to put on a vector A, which will be this one. Now, if the size of vector A plus the size of vector B equals the size of both of them added together, what does that mean? I'm going to draw a second vector. I'm going to draw B on here. Okay, so there's A, there's B. What does vector A plus B look like? So can you guys sketch this yourselves? Then can you try and add a sketch of vector A plus B? And can you tell me what the significance is if both of those things are the same? If A plus B, mod of A plus mod of B equals equal to mod of A plus B. Remember, A plus B is a vector of itself, yeah? Okay, I'm going to give you 3 more minutes to see if you can work it out using that sketch. Please comment in the chat whatever you think the answer might be. So 3 minutes starting from now. Cool. No comments. I think Elizabeth sent me a message. What did she say? She said, Yeah, parallel. Good. Well, good spot. Okay. Yeah, this one is tricky though. If I draw a plus b on, a plus b is. That's good. A plus b is this vector here. From my sketch, those are not the same size. If you imagine it as a triangle, a plus b is going to be way bigger than a. Vector a plus vector b in terms of size is going to be way bigger than a plus b. So for them to be exactly the same size, a plus b have to be in the exact same direction. Yeah. Otherwise, a plus b. So the significance is they a and b are parallel. In any other situation, a plus b would be more than a plus b, because you got that angle there. You know, that is a longer distance than that is. Always, unless they're parallel. So yeah, the significance there is that the two vectors are parallel, but you can only really spot that from a sketch. Okay, part 2 is completely unrelated. So looking at part 2, two different vectors, m and n, are such that m is free and m minus n is 6. So if I draw these, there's m, there's m, n can go over here, and then. Mod of m is free, so we'll do that in a second. M minus n, so m take n is the same as this vector here, because m take n would be m, wait no it wouldn't, talking rubbish. I'm just got the direction wrong. M take n, so we need to go, imagine we're starting at n, we go minus n, to minus n, which will take us back to the origin, plus m gets us to here. So that there is m take n. Direction doesn't really matter though, based on what they want us to do. So m take n is 6, so this has a side of 6. M is free, that has a side of 3. So I can just unlabel these now. We want to try and find the vector between m and m take n. So we're trying to find this angle here, let's call it x. We know the angle between m and n is 30, so we know that this angle here is 30. So this is just a trig question. You can pretend it's no longer a vector question, I can get rid of the axes because I got a good sketch. So this is going to be a sine rule question to find the top right angle and then use that to find x. So if we call this one here y, we can say 3 over sine y equals 6 over sine 30. So therefore sine y equals half sine 30. Half sine 30 is a quarter, so sine y equals a quarter. If we arc sine that, I think we get 14.5 maybe. So arc sine quarter, we get theta, sorry, we get y 14.48. We're now going to do 180, take 14.48, take 30. We get 135.5 degrees. So common mistakes to this one is to draw it wrong or not draw it at all. I think you can just do it without a sketch and actually calculate the wrong angle. So sketch really important for this one. Right, next up, let's get rid of all the answers here. Okay, do you guys try this one? So this is a relatively straightforward vectors question. 4 marks, I'll give you 5 minutes, I'm feeling generous. So Any ideas, guys? Please give me some feedback. Give me some comments just so I can see if you've got it right or not. Should be pretty easy, this one. So, point A, position vector 3, 7. Point B is that. Find AB. So we're going to do AB equals OB, take OA. So AB is OB, 8, 3, take 3 minus 7, which is 5, 10. Then find mod AB. That's going to be 5 squared plus 10 squared, which is 125 square rooted, which is 5 root 5. Cool. Right, this one's a bit trickier. Not much, but a bit. So, 5 marks. Oops. Alright, I'll give you guys 6 minutes. Please give me some feedback though. Give me some answers. Write some stuff. All right, cool. So we know point A, we know point B, we know point C, because point C is about unknown. Point D is AB equals BD. Find position of D. Okay, so if we find AB, remember AB, OB take OA. So AB is OB, so 4 minus 2, 3. Take OA, 2, 3 minus 4. We get 2 minus 5, 7. So that tells us that BD is 2 minus 5, 7. And BD would be OD take OB. So 2 minus 5, 7 is OD, which we're trying to find. Take away OB. OB we know was 4 minus 2, 3. We can add B onto the other side and get OD equals 6. Minus 7 and 10. Cool. So that's D. Given that AC is 4, find A. So we're going to find A to C. Which will be C take A. Or OC take OA. So OC we know is A, 5 minus 2, take A. A is 2, 3 minus 4. We know the size of that vector is 4. We can use that to find A. So I'm going to work it out. A take 2, 2, 2. So A take 2 squared plus 2 squared is 4 plus 2 squared is 4. All square rooted equals 4. So we'll square both sides. So we get A take 2 squared plus 8 is 16. Take 8 from each side to get 8. Square root both sides. So A take 2 is plus or minus root 2. They told us here that A is negative. So therefore A is going to be 2 minus root 2. That's it, done. All right. Next one. So now it gets a bit trickier. We're trying to prove that this thing is, no, what we're trying to do, prove that the diagonals bisect each other. Right, we're going to give you 10 minutes for this one. Give you 10 minutes for this one because it is a bit trickier. Sketch it in your notes, and remember you're trying to find two roots to the same point. If you call the intersection x, I think it's slightly easier. But yeah, give that a go. So 10 minutes starting from Cool. All right. Yeah, a bit more challenging this one. So we're trying to show that they bisect. So let's draw them on. So we got AG, and we've got OF. And we'll call this point in the middle X. So I want to try and find two different ways to get to X. So way one is going to be OX is simply lambda O to F. It's a nice easy route. We are just going from here to there. Route 2, let's go from O to G. No, let's go from O to A to G, or O to A to X. So route 2, OX is OA plus mu AG. So let's try and find expressions for those two. So O to X is equal to lambda O to F. So to get from O to F, we're going to go O, A, B, C. So ABC. So that's done. The second one, OX, well, O to A is just A plus mu AG. So A to G is going to be minus A plus B plus C. Cool. Now, if those two paths, they both lead to the same place, they both start at the same place, therefore we can set those two vectors equal to each other. So lambda AB, should equal A plus mu B plus C minus A. We can look at the A bit separately, so we can say lambda is 1 minus mu. We can look at the B bit separately, so lambda is mu. We can look at the C bit separately, lambda is mu. If we solve two of these simultaneously, like these two, we can say mu is 1 minus mu. And we get 2 mu equals 1, therefore mu is a half. Therefore lambda is also a half. Therefore, did they bisect? X divides both of those things in two. And we know they meet because they take the same kind of distance to get to the same point. Okay, so that's that one. I think there's one more to try today. We're going to run out of time. Exactly the same as my other group. So E plus F, start here. If you guys could try this, it's 9 marks. I'll give you 10 minutes. That's weird. It's exactly minute to minute the same length as my other run through this lecture. So I'll give you guys 10 minutes now. If you need any help, ask. But I'm not going to go through it today. We're going to go through it at the beginning of tomorrow's lecture. So give this one a go, please, guys. Alright guys, I'll see you tomorrow to go through this one. Cheers, thank you.